Hello, everybody. So, ready for night 2 of our SDEV 200 class, getting started with Java. I know some stuff went kind of quick the other day, and I usually try to mention it on day 1. Everything we looked at the other day, that was in preview mode. We're going to see the stuff in detail. And just day 1, the agenda is usually go over the syllabus, and then fill time. So we're going to see all the stuff in detail, and everything we saw the other day was kind of preview mode. If any of it seemed to go fairly quickly, especially that stuff with NetBeans at the end. We're going to look at NetBeans in detail. Put JSP pages on here. That way we can. JSP pages are Java server pages. Those are the ones where we intermingle Java code with HTML code. So the Java code runs on the server, and then the tags that we actually write in the file get replaced by the result of that code for the server to transmit to the client. So we can make very powerful dynamic pages that way and make things look really, really nice, because HTML has a lot of, we have a lot of the ability to make things look very, very nice in HTML and CSS and all of that stuff. So they tie together. Let's see. Look at refactoring. You want to be careful typing code, because said it a few times the other day. Java is for big things, which means we're going to have lots and lots of files, lots of different objects in different files, and we'll have build instructions for how the computer runs the compiler and puts all those together, and a lot of different files spread out amongst a bunch of different folders. So if we suddenly decide we want to rename a variable, we're like, oh, when I called that Java object 2, that wasn't a good one. Should have called that customer invoice object or something. And we want to rename it. We don't want to go over there and hit the delete button, hit the backspace button, and retype it. Because then we have to do that every single place it's typed. We want the computer to do that for us. So that's a very important one. If we have lots of files, things spread out and interconnected, we don't want to risk us missing something or making a typo. We want to rename something. So we'll see how to have the computer rename it all the way across the project. That'll be an important one. I'll look at the local main again, because we wrote up the main public static void main, taking an array of string. We usually call it args, and we didn't really look at what args are or how we give them to the machine. So we'll look at that. The parameters we pass in from the command prompt or terminal or shell, or however we actually start our program. Remember, even if we're clicking on pictures on the screen, that's still running a terminal instruction in the background. The programmer already tied that instruction to that picture.
This meeting is being recorded.
So we want to see what those parameters do. Do they get feedback there? Okay. Yeah, the guys here in the classroom we're logging in extra machines so that they can see the example nice and clearly right there on their desk. Which I did that even before the pandemic. I used to use Google Hangouts because class examples are all code-based, and that's kind of hard to read from the projector, especially since most computer people sit in the back row. So everybody in the classroom would be in the back row trying to read the text off the projected onto the whiteboard. It's like, yeah, let's just all sign into Google Hangouts or something. So we'll look at the local main again, talk about beans, get our first view of that, and have some other notes on here. So a few things to talk about. We're going to stretch it out over 16 weeks. Hopefully they'll learn Java really, really well in that time. Does anybody have any questions before we get started? Okay, 5 seconds of silence. I assume that means no questions. So let's go ahead and pick up with what started to seem rushed the other day. And we'll look at a simple file or simple thing, just printing some lines out, sort of thing we can compile easily. One thing about the project management, we did see the import segment the other day, right? We imported something else, brought that into our thing and then used it. Well, if we do a lot of importing our own objects, then the order we pass it into the compiler matters, right? If we have a separate file, maybe it's called employee, has all the employee, connects right to the database, company database, and has all our employee data, and we're going to import that into our main. We can't compile the main first because there's not a compiled version of the employee one. So the order matters. And that gets very confusing as things get bigger. So that's one that IDEs handle for us. And that especially is the thing that those project managers handle for us. We'll be using ANT in class. We're definitely going to take a look at the other ones and see how they go, because Maven was wrote by the same people 6 years later, so there was lessons learned when they came back into the second one. Had a lot of improvements to make right from the beginning. But one of those was it's automated processes, so we might as well do it in machine style. So it's kind of a mess of folders to deal with. It's not exactly the most user-friendly thing to start out with. We'll look at those other ones. We'll probably use ANT mostly because that's much more human organized. There's less folders to dig through to find any of our files and kind of see how that build instructions go. But for right now, we're going to start off simple, right? Something simple, just all it's in one nice file that we can file and work with. So I'm going to open the Windows terminal. So Windows Terminal has been around for a couple years. It's the one they actually have on Windows 11. It's really nice. It's got the PowerShell. It's got tabs, so we can open up multiple ones. Open up Git Bash and command prompt, and have lots of different ones, or split panes. Fully customizable, and the settings are customized in JSON. So everybody in here is software developers, you probably heard about JSON. So if we want to customize this terminal, it's just a great big JSON file, which is kind of really nice. That's not really a thing for this class, just trying to sell it, point out that it's a really nice one whenever you get around to moving it. But that's the one that comes on Windows 11, so we'll use that. So we need to create a file to work with. I'll go over to my working folder. I better make a new folder here. That looks like there's a bunch of stuff there. I'll make a folder called second. And then go into that. There we go. Now we got a nice empty spot to work with, a bunch of clutter everywhere. And I just remember I'm going to put GitHub on the list for tonight, because when you submit assignments to me this semester, you won't go upload your files to IvyLearn. You'll upload your files to GitHub, unless you just really want to use a different repository. Like, I don't like Microsoft. GitHub was nicer before Microsoft bought it. I want to use CNET. And I'm fine with that. As long as you're going to upload your files to a repository somewhere, and then you'll send me a link to the repository. The standard way to transfer code. One reason for that is because security protocols don't like when we download code, executable files from strange places, such as a browser. It doesn't want us to, especially for Python. Java would have to be compiled, but that can still be automated. But Python is a great example, because pretty much every computer these days is going to run Python. We're going to run Python right from the text file. So if you downloaded that from the internet and just ran it immediately, that's a big security risk. So security protocols block programs or code files from being downloaded in a lot of situations. There's an exception in a learning management system But that's not good practice since it's gonna be blocked everywhere else, right? So we're just gonna use a code repository, which is the standard way, and you'll just throw your stuff on GitHub or whatever repository you wanna use. If you wanna use a different one, GitHub is the most popular by far. So you just load your stuff on GitHub and you'll submit, and then you'll just send me the link to GitHub. So we'll look at that tonight first. All right, we'll look at that tonight as well. But first, let's look at a program when we're not so much of a rush or preview mode like we did the other day. So I'm gonna create a new one using a regular text editor, and then we'll get to the IDE. So I want to show the command prompt. So I have the Sublime text editor. So there's different ways to do it. You want to open your text editor and to have something to pass into the as for command line parameters, I'm just going to do a knock knock check. So like if when we start our program, we also pass in the string knock knock, then the program will respond appropriately for a knock knock check. But if we just start our program, we'll have a different response. Does that make sense? It's kind of what I had in mind there. So joke.java file, and I'm using the Sublime text editor, and several people that I remember from past semesters were usually using VS Code, so you would just type code and however you would, whatever your preferred text editor is, someplace to type the code. And it's just text. You can use, I have written programs with cat, like right in a bash shell before, and just concatenated text together right in the bash shell instead of actually ever opening the text file. But that is really just, that was only ever done as a proof of concept to show people that it is possible. One of those things. It's I think that's how people had to do it in 1974. So we don't necessarily have to do that way anymore. So we saw the other day, first thing is everything in Java is object oriented. So everything has to be a class. We need it to be accessible. So our first two keywords is we're going to make a public class, and then we give it a name. And in Java, the first class in the file, and we always try as much as we can to do one class per file. Try to keep it as a 1-to-1 ratio. That is one of the first things in beans that we're going to talk about soon. So try to keep it a 1-to-1, one class per file. Obviously, nested classes have to go in there. And if you have a large program that only has 2 classes and you want to put them both in the same place, it's not going to crash when you do it that way. But it does have, the first one has to match the name of the file. So make a public class named joke. And then some curly braces to say where the code for that class definition or blueprint for an object is going to start. And this is just going to be a main one. We're just going to run this one thing here. So we'll need our main method, which a main method is special. The main method is the very first initial starting point. So we don't have any objects. We don't have anything going that we could use to instantiate an object. So the only place we can get stuff is from the blueprints for an object. We can't get an actual one. We have to look at the design for the object, which means we have to use a static one. Again, we want it accessible. So public static. So basically, there's different places to use static. Obviously, good memory management. If there's only one copy, we're not going to waste a bunch of RAM. But we have to use it when it's the very first thing we need. Or some stuff we'll see with databases later. We need to set up a factory before we create our first object. So we have to look at the blueprint and do some stuff, do some static stuff there. But that'll come later. Just the main thing to remember is static means there's one and only one copy. So there's different situations where we need it. We're not going to return anything when we're done. That's a big difference from C++. In C++, our main returns an integer. And that way when we call it from the command prompt or bash shell or PowerShell or terminal or whatever we use to actually start the program, we can check to see what integer comes back and confirm that everything worked. Handle crashes better. But for Java, it's going to run and when it finishes running, it's done. It doesn't send anything back. So void is we return void, and main has to be called main, and we have to set a place to accept any extra words that were typed into the bash shell or PowerShell or terminal or whatever we actually use to start our program. There might be some other stuff that needs passed in, so we need a place to accept it. And the standard name for that is args. It has to be an array of strings. We'll see arrays in. I think everybody's seen square brackets before, right? Everybody knows what square brackets mean. I see head nods here in the classroom. So we have an array of strings, and that was the one we didn't look at the other day that went to sure you all. And since this isn't, there's some prerequisites for this, I'm gonna jump ahead a little and go ahead and throw a selection structure in here so we can do something with those args. Everybody has seen an if-else string. Not in Java, but in some language or another. And it's very similar. Our keyword is still if. Then we'll enter a condition that needs to be in parentheses. So if args index 0 is equal to knock knock. That'll work, yeah. I was trying to decide if I should split that up to 2 words or just one, but we'll just keep this short. Which means we'll have to wrap in quote marks there in the terminal, right? So everybody's seen that before. In PowerShell, command prompt, bash shell, things are space delimited. So if we want to include a space, we have to remember our quote marks on it. That way that counts as one string. So if that's equal to knock knock, we'll print out the message system.out.print. Who's there? Our standard little response to that. And if it's not, I'll just jump to the if else. Since we're looking at it, if we need the if else, it's 2 words separated by a space. That's very different than Python. We couldn't do that in Python because Python is white space matters. That's a language I know everybody in here, or I'm fairly certain everybody in here has seen before. We can't spell it out in Python because white space matters, but in Java we do. But here I'm just going to do 2 of them. So if and then else. If it's not that, then we'll do system.out.print line. That's a lot to type every time, right? I turned it off in my text editor here, but it'll definitely work when we get to Sublime or to NetBeans. I'm in Sublime right now. I intentionally turned it off so that I could show you this. When we get to NetBeans, we'll be able to type S out and hit tab, and then that'll switch to system.out.print line. Because that's a lot to type, and we're going to type it a lot of times. And humans are prone to making typos, so somebody went ahead and Apache was like, oh, let's go ahead and just put 4 letters instead of however many that is, 15. That way people are less likely to make a typo. But I turned that off here, and some text editors will do that as well, since it's so common. System.out.print, say, what do you want? That way it's different than the knock-knock response. Actually, I'm just going to print go away. We're either telling the knock-knock joke or we're not. That way it prints out something that spits out. So that way we're done with the else block. If we're just printing that, I'm going to print line. So what's a knock-knock joke? So knock-knock, who's there? And we need an input. Saw that the other day. There's lots of ways we can get inputs. That's something on the notes tonight. We're going to look at input strings as an example of that. But our basic way is a scanner. So we have to import a scanner library. come up here, import Java, util, wildcard selector. Has everybody seen that the asterisk used before that way? Standard for query languages, it's a placeholder. Whatever words the computer can find that would fit in place of that asterisk, at compile time, it will stick them whatever words it can find there. So if we're typing the whole thing, it'll work like that. We can type the exact one we want, but it's in the java.util library. So we want something from there, and we want a scanner object. Again, with our Java syntax, it's a strictly typed language. So we have to say what type of data we have. And once we have it, we have to stick with it. But the computer is going to set up spot in memory beforehand in advance. It's going to go reserve as a spot in memory. So we have to start off by saying what type of data we have, which that's one of the big things that makes strictly typed languages much faster than open type languages. In open type languages, the computer just has to guess how much memory we need, adjust if needed, change it dynamically. But in a strictly typed language, say, well, we have some scanner data. So computers, the CPU is going to jump over to RAM and reserve as enough space for scanner data. And that's all we can keep in there. So it's very well managed memory, which makes it faster because then the computer doesn't have to waste any resources trying to figure out how much space it needs to hold our data. I'll call it the keyboard because that's where it's coming from. And that's going to be assigned a new scanner object. And what are we wanting to scan for input? There's lots and lots of things we can scan. Java was originally being created for smart TVs, so scanner has to, the name comes back to like a remote scanning the channels to see which ones work. But there's lots and lots of things. In our case, we're scanning the keyboard, which is our standard input for the system. So system refers to our operating system. System.out by default is going to be the monitor. And likewise, we have a system.in that by default is going to be the keyboard. So knock knock, who's there? We'll type something. And then we need to get what we're going to type. So it's coming from the keyboard. It means it has to be a string, right? So our keyboard only does strings. So I'll have a string, user input. Another thing that will relate back to beans when we talk about those, I keep adding things to the list. So maybe we might not get to beans until next Tuesday. Explicitly, but it's we'll get to there soon. The conventions, because when we follow the unwritten rules of Java, just the agreement that we're all going to write our code the same way, there are some very powerful things that will show up later. We'll take a look at a couple of them when we're talking about Java FX, a graphical user interface package. In particular, when we do tables, we'll look at what we call observables, which involves us parsing someone else's code so that we can dynamically change their code and our code. Not just parsing the output of someone else's code, parsing their code so we change their program on the fly. With that subtle agreement that we're all going to write our stuff the same way, we get powers like that. So it's a good convention to stick with. I'm going to follow the syntax on the line above. I thought I'd turn the predictive text off. Because that is what Java, that's our basic Java syntax. See how that's that similar thing on both lines? What type of data do we have? A reference name for it, the assignment operator, and then a new instance of that type of object. This will do exactly the same thing as the line above it. Usually we don't do it, there's not a lot of overloading in Java. If we need to do any overloading, which we'll talk about soon, we overload methods. But there are still some overloads from the early days that show up, and one of them is those line 9 and 10 on my screen there are equivalent. Those do exactly the same thing. Most people type it like line 10, but since we're in day 2 of class and our official example, I'm going to go with that full Java syntax. Data type, reference value, and then we assign that a new instance of our class. And we'll pretty much everything, every time we set something up, it'll follow that condition. Then we can put something in that string because that just gives us a blank string. So let's say user input. This is going to be assigned. Sorry, I thought I turned the predictive text off. I'll turn that off before the next. Actually, we're probably not going to use Sublime much more after tonight. I'll turn it off anyway. It gets in the way in class examples, that's for sure. So user input is going to be the next thing that's typed in the keyboard. So say knock knock, computer gets that, does the who's there, then we'll kind of type the first part of the joke. And then we want to put that into user input. So we have the keyboard dot, and then we have a few options. This is going to show up, it's not predicted much. So next would be the next thing, and there's a whole bunch of preset delimiters. It would look for commas, spaces, colons, the normal things we use to delimit or separate data fields. It's going to look for a whole bunch of them. But for a joke, we might have a whole bunch of them. Oh, and before long, we will see that there's also a next integer, next double, next float. So we can skip over words and look for the next number we find if we have some idea. Or there's just a next line. They'll just grab everything that they typed until they hit enter. So whatever's typed all the way, next time it hits a line break, either a line feed, a carriage return, or the carriage return line feed combination, which a lot of y'all are pretty young. So the reason we have multiple ones, it goes back to typewriters. Everybody's at least seen a picture of a typewriter, right, in a museum or something. And the carriage, that wheel that pulled the paper through, a line feed would just turn that carriage. So if you were halfway across the page and then turn that, you're still typing halfway across the page. There's a carriage return would turn to the next line and move that carriage back to the beginning of the next line. So that's why there's two separate ones. In a computer sense, usually if we just do a line feed, the next line is empty, so it goes to the beginning. It's not always the case, so you do have to watch for that occasionally. And when you see the situations where that shows up, it makes perfect sense why the next line was not empty. But if almost all the time the next line is empty, so when we go to the next line, there's no place to go except the beginning of it. So carriage return and line feed seem the same on a computer. So we'll grab that next line and then print something out. So again, we'll ask the operating system for access to its default output to monitor or terminal or wherever we set to make the default output. We'll ask the operating system for its output, and then we'll print the line, the user input, so whatever they typed in, plus loop. Finish out the little cheesy knock knock joke. Or I'll do one of the one-liners. I guess if you have something in mind, you could add another line there for the final punchline. There's also, I'll just do a cheesy one to kind of finish out this example and show how those work. Does everything there make sense? That's a lot of the key concepts. I think starting out slow, we are gonna get faster. So we've seen those key concepts. We don't need to talk about them every single time. But hopefully that all kind of makes sense. And the general logic of a selection structure and printing stuff out makes a difference. The big difference for those that are used to working with Python is there's more than one place we can print stuff. We're asking for the actual operating system's output to print to. So we have to be specific about where we print to. There's not just one option of what print does. So save that, and we need to compile it, which I can do right here in Sublime. I'll open my terminal, that way we're still looking at stuff. Most text editors do have a terminal accessible. If you have a decent text editor, a lot of people don't take the time to look for them. But unless you have the really, really, really basic terminals like Notepad or and Text Strangler, which is kind of the super basic equivalent of Notepad, you can still access your terminal from in there. So we usually have access to the terminal from it. So to compile this, I do this. Let me check something real quick. No, that's not going to work. I was thinking the Kali system, Kali Linux system would have a shorter prompt, and it will, but I have a different version of Kali on my. I have a different version of Java on there. Oh, actually, that'll be a great thing to show you. So let's compile it. We saw that the other day. Java C is our compiler. And then we need the name of the file. We want to compile the joke.java file. It'll go through there. No error messages. So a no news is good news situation. You don't get a confirmation. And then to run that, we'll call the Java virtual machine. So Java is the command to start the JVM. I'm probably not going to say that all the way out again, but that's how we get cross-platform, write once, run anywhere sort of code. We write the same code and works on every system because it's actually a virtual machine installed on that system. So the virtual machine handles all the operating system specific details, and then we can run the same code on that virtual machine. And then we just need the name, no extension of it. Oh, got a little error there. Let me do that over here. Java choke. So there's kind of what our error messages look like. Probably seen something similar in other languages, right? Everybody know what that message means? Anybody want to tell me what went wrong there? Oh, let me zoom in. And yeah, that's also a good example of spelling things out in Java, right? That's a long one, but array index out of bounds. So we tried to check index 0, but said index 0 is too high for our array. Because when I started it, I didn't pass anything in. So we probably also want to check and make sure that's not in. That makes sense? That should be something you may have seen before, right? Not just if this thing is there, but if this thing actually exists and is there. So different ways, we can just check the length of the string. If our index number 0 dot length is greater than 0, and it's like that. So our and is 2 ampersands. We don't get the word. We don't get the option of the word. And's gonna be 2 ampersands. Bitwise and will be 1 ampersand. Same thing with or. 2 pipe symbols for or and 1 pipe symbol for bitwise or. If we're in Java, I will sure, at some point later this semester, we'll actually go through an example of those. But really, if we're going to use those, we're directly coding the how our binary code changes. So we might see that as later in the semester filling time. That's a hard thing to squeeze into that classroom. So does the logic make sense there? We don't just want to check to see what it is. We want to make sure that it exists first. We can also check that it's not null. If arg0 does not equal null. Multiple things we can check. But we're going to want to use the length variable a lot, so I wanted to see that right off the bat. And we'll compare against null later. So if it exists and it's equal to the words knock knock, then we'll tell our joke, otherwise we just print go away. So I'll come back over here and recompile it. So Java compiler, compile the joke.java file. No error messages. So now if I start the JVM and run that joke program, sorry, I forgot to save it. Notice there's a little dot here. So I made the changes and then saved the changes. That's an important step. And now try recompiling it. Variable. Okay, it didn't like that. So I will go with the other one. If that is not equal to null, and for those coming out of Python, it's similar to none. It's close enough to none that we're always going to think pretty much anything will fit that we'll see in this classroom. It's going to be equivalent to none in Python. But there's some high level differences between the two, or low level differences. Yeah, low level down to the ones and zeros. There's a big difference between null and none. But for anything we do in the class, we'll just call it equivalent, and we're going to think about it the same way when we put our. If it's not null and happens to be equal to this, let's see if that works. Oh, did I save it that time? No, I did not. Save. And then compile. We compiled. So Java run the joke program. I'm gonna do this joke and then pass in knock knock. Then I'll figure out why that's not working. Oh, looks like I got my logic backwards. It's not null. Those words were supposed to be the first one. Does anybody see what the problem is? Come back over here and run it. I'm gonna knock, knock. Oh, thought I was going to go into this one, but it seemed to go into the other one. Does everything there seem fairly solid? The logic looks pretty intent. This will be important. The way Java stores strings, those might not be equal to equality, because they could. The equal means that it is stored in the same spot in memory. So if our new string was stuck in the RAM chip, where do we create that? Oh, well, if this string was stuck in the RAM over in the RAM chip at bit 9,842, the only way it is equal to this string is if this string is stored at bit 9,842. I think it's the number I said. Which oftentimes when we do that in our own Java code, it will work. But here, that's a problem. So we need to use a method for this comparison. Equals knock knock. So this will compare character by character. Oh, which I should mention now, since that's the first time the character is shown up. Our single and double quotes are not interchangeable. Some of y'all may be used to that from languages that they change things around. Single quotes are characters and only individual characters. Double quotes are for long strings. So they are not interchangeable. So what was that? That was, yeah, the error message and then the general error. For those who haven't had me in class before, I like to throw error messages. We could avoid them like that finished polished version you see in textbooks. But that's, you all know that's not how it goes when we write code. I'd much rather show you how to deal with the error message when you see it. Because that's what we're going to see when we write our code. We're going to see those error messages. We need to know how to deal with them. So come back over here, compile this again. Java C Java. It compiled. Java, just run it. Oh, index 0 out of bounds. Let me go back for a second. I didn't think very hard about why that wasn't working, what I originally wanted to do. So I wasn't going to use, no. I did not need the index there. Sorry, that one was a mistake. That wasn't one of the mistakes I was planning on making to look at error messages, but I guess it'll work because that's an important one. Length, an array has a length, right? But index 0, a particular element in the array might not have a length. So we can't just automatically check for that. So I'm going to check the whole array for a length. If the length is greater than 0, then we do have an index 0. But if it's not, then jump down to this stuff. That's what I originally meant to do. And yeah, just made a little typo in there. The other messages were planned. So, okay, compile. And there we go. So if we just say run the joke program, it's like, no, I don't feel like telling a joke, go away. Right? Jumps past this if statement. But if we say Java, tell a joke, and then give it the parameters knock knock, which space delimited in our terminal, so we need to make sure there's quote marks. Gonna ask who's there. The owl goes. And there's the joke. So that's what that string, that array of strings in our main method is. Is everybody following along, able to get that to work, make sense of it, or get enough notes jotted down? You can fiddle around with stuff later and kind of go from there. So that's what our main method looks like, but compiling it ourselves, that gets to be a lot whenever we're in, whenever we have decent sized programs, and Java is for big things. So we're usually not going to write small things in Java. which means we probably don't want to compile it ourselves to keep track of all that. And that's where some of those tools in the IDE come in. So I'm going to copy this over to the IDE and see how we would pass command prompts in there, because if we type it in the IDE, we have to have the same main method, but we don't call it from the terminal, right? We have that green button we click on. So there's not a place to type words on that green button. So let's jump over to NetBeans and see where to enter those at. And then it'll probably be time for a break. What time do we end tonight? Is it 8:50? Okay. Still not quite used to the whole the new schedule. So I'm gonna create a new NetBeans project. And that thing I just mentioned, when we have lots of files, so we have to keep track of the order of how we compile them and where we put the original source code and where we store the compiled versions and our project manifest and all of that stuff. It's gonna get really big, but it's not complicated. It's tedious, time consuming, but there's not a lot of thought involved. The perfect thing for a computer to do, right? There's not a lot of thought in typing up, okay, folder, source file goes in the folder called SRC. The build file goes in the folder called DIST for distribution, source and distribution. Once the organization is in place, there's not a lot of thought left. So perfect thing for a computer to do because it's just tedious and time consuming. So that's what these are, our project managers. Maven is a centralized location. We get one build file, put all the information in one place. Gradle's the opposite of that, it's distributed. We have hundreds of build files, and it's rare that any of them have more than 3 lines tops. And a lot of them are going to have 0 lines. Since it's an automated process, the computers just can go ahead and create them. If we wrote them manually, they would all at least have 1 line. But some of them are just going to be files that exist with nothing in them. So one of those should strike you as really, really good for a traditional disk drive, and the other one should strike you as really, really good for an SSD drive. Because if we have 100 really, really small files that have virtually nothing in them, we can grab those in one flash. Versus a disk drive, if we have one great big file, our time bottleneck there is moving the read head into place. So we only have to move the read head once and then we read the whole file. So that's why there's different versions. Ant was one of the early experiments in that, and they use human readable form, so it's kind of nice for classrooms because everything's organized nicely and it's spread out. Maybe not exactly the way you would do it, but probably closer to the way you would do it in Gradle or Maven, which are optimized for the computer, not for reading. So we have to, it's nice to ease into those instead of jumping in. Okay. So we'll just do a Java project, create a new Java application, give it a name. I'm going to call the application joke, create the main class, and notice it wants to call it joke.joke. So that has to do with packaging. When I click finish, we'll see some stuff. This out. So this comment right here, that generates a web page. That's one of the things we're going to look at shortly after our break. Java docs, there's a standard notation for it. It's a multi-line comment. So from the slash asterisk all the way down to an asterisk and a slash is going to be commented out. And if we start with 2 asterisks, whatever the plural of that is, then it's a special comment that when another program will look through there and generate a website from that comment, which is much better to read the documentation from a web page than from comments in the code, right? That's kind of hard to read. We can go to a nicely styled website with links and nice color coding that's easy on the eyes. So we'll see that, and it's been in Java. Java was one of the early, that was one of the things first developed in Java, and they're all over the place now. So they're called Java docs. And single line comments are 2 slashes. And as far as the useful ones, / to do in all caps will go on to your task list. If you start your comment with / to do, it'll go on the task list. Those who've had me, those who have seen Python in one of my classes, we would have seen the Python version of that, right? Comment at to do, to in lowercase. It's the same thing in Python. It automatically puts it on a comment, on a task list where you can check things off that you get it done. Those are the 2 most useful type of comments. Any other type of useful comment, you probably have to parse through the text file and do yourself, but don't know how to read it. Before long, maybe not in Java, but in some language or another, you all already know how to read in a file and manipulate the string there. So you can do stuff with the, we can make our comments do things. They don't have to just sit there in place. But I'm going to get them out of the way for the class example. In general, for class examples, they're cluttered, right? They're kind of sitting there. Sometimes after class, if we're covering something complicated, I will add comments in after class and then send out the example. But they get in the way of the point we actually want to look at in our class examples. So I'm just going to copy that stuff over. Oh, and notice this package. And I call those other things project managers or package managers. Packages are our libraries. So if we wanted to use this again, we would say import joke in another program. So we import a package. So notice it matches the folder name and it's all lowercase. And that means automatically did that with our project name, but packages are typically all lowercase jammed together. All lowercase letters, jam all the words together. And that's what you call your folder to organize stuff. And then that's what you import into other libraries. But that's still a couple weeks away, so that note was just a preview thing. Talking about all these things repeatedly so we can, we'll know what's going on with them. And now I'll just copy all this stuff. Copy and get this out of the way. And it's just pasted in here for the main method. Some of our stuff should be similar. So the indenting's all different than the other ones. So if I highlight it and do Shift Tab, hold down Shift and push Tab, it'll undo the indenting until things line back up. Oh, and we have curly braces and semicolons, so line breaks are only for us. White space will be deleted before it compiles. So we could write this as one long single line, and it will run exactly the same, because the curly brace means, I'm going to say end of instruction class, talked about the technicality the other day, that only matters if you start working in machine language directly. There's that technicality that it's actually next instruction, but because of where we type it, I'm going to say end of instruction every time we say that in class. So we have our end of instruction symbol, and then we have our start block and end block symbols. We could do one great big long line and write 1,000 lines, what we would call 1,000 lines of code. It would just be impossible to debug, right? So white space is only for our benefit. Tabs, indents, wherever you want to put it, white space gets deleted before it compiles. Oh, and need that import. So it could come up here and type it like we did in the text editor, or in NetBeans, it's Control-Shift-I. Control-Shift-I as an import will automatically do it. And obviously you can go in settings and tell it to do that automatically when you do it. Over the years, I've found that I like to recommend against doing the fully automatic one. Do the half automatic one on a keyboard shortcut, because then if there's options, so like if down here we wanted to say node n equals new node, That's one I know is everywhere. When I go to import that, Control-Shift-I, it imported something. But there are lots of nodes. Was it really the W3 consortium document object model node that I wanted there? Probably not. I was completely making that up, but it's very, very unlikely that that is the node that I wanted from that. So alternatively, it usually shows up when you do the Control-Shift-I, but if you click over here, you'll get a list of things that might have node in them. Is that the only one that's imported? Okay, yeah, that one can't even be instantiated. But there's lots of different nodes. I was actually expecting it to pop up the like tree node, because there's a collections java.collections.tree, which is made up of a whole bunch of tree nodes. That was the one I was expecting, but the fully automatic ones can be a bit problematic for that. So I guess that was even better than what I was anticipating for the example. So the half automatic ones where you can see a list of which one you want instead of it just happens as soon as you're typing. Is definitely what I would recommend. So all that's in there, and Control-Shift-I to create that. Alt insert is another very useful one. We don't need it on this one, but when we make where everything's object oriented, so when we make objects, we need constructors for them, so we can automatically insert the constructors. And notice I made that plural. For those who are familiar with Python, that would be a singular thing, right? So we will automatically import our constructors, however we want to create the object, or our getters. There's no getters and setters. The two-string thing can override any property that exists. There's no properties to make getters and setters for. So Alt Insert and Control-Shift-I are two of the keyboard shortcuts you will use most often in NetBeans. Automatically insert the code, or automatically import a library. So now that we have that, we should be able to run this. And there's no place to type knock knock there on the green button, right? So the only option I get is that not going to tell the joke. So if we need to pass in for command terminal instructions, I guess that would be the terminal term. If we need to pass in terminal instructions, we come over to the projects over here on the left. And if you lost track of that, under Windows, IDE tools, it's projects, it's somewhere around here. Oh, there it is, right at the top. Oh, Control+1. Control+1, a very simple keyboard shortcut, will automatically open that one back up. We won't need that. So if you lose track of your IDE, the turning the windows back on is over here. But over here, if we right click, then we get a bunch of things for it. So there's new, where it's going to try to suggest what we want to do. Oh, I guess it's doing that W3 stuff, because I have of the 5 projects over there in the project browser, 3 of them are web stuff. So it's thinking I'm wanting to do more web stuff. It put HTML file right at the top. So if you got Java, this would probably be the HTML file. But we can create a Java class, put it in there, and choose lots and lots of different types of files to create right in our project. All that stuff's here. There's the right click, and there's the generate Java doc, those comments I was talking about. We'll make an entire website from our comments. We'll look at that first thing after the break. We'll click that button to make those. Maybe not making ours, we'll look at some of the official Java docs, because see what the style sheet looks like. You may have already seen it right now. Debug stuff, run, rename, that'll be an important one. If I go to rename it, notice it asks about, there's options options on how to rename. Same thing with our variables. We don't want to just type a different name. That could be a mess with like all these libraries we brought. We have all these libraries, and somewhere up here should be a manifest. Manifest is probably over here. Oh wait, I'm in hand. The manifest is automatically generated, but I come over here in the NB project. We have these files, our build instructions, the properties from our project. Up here we have our manifest, which is with and is automatically generated. In Maven and Gradle, we would actually see stuff in the manifest already, but with and it said it will be automatically added at build time. So all that stuff is handled for us. It's automated. But we don't anything. If we created this variable called keyboard, which that's going to show up in the build file and the manifest, and all that, and the properties, all that other stuff. So we don't want to just go over here and hit backspace and type a different name, because that'll mess up all that other stuff. If you right click and go to refactor, there's your rename button that will change it every. Notice I didn't highlight the word, I just put my mouse over it. When I clicked there, it did the half highlight. And when it's half highlighted, there's the actual highlight. I don't know if that color change came through on the screen. I clicked once and it shows there. I guess you can maybe see the difference between those. They're both light blue, but this one's actually highlighted and this one's half highlighted. But either one, then right click on it and refactor to rename it. Or a whole bunch of other stuff. We'll see down here. And a whole bunch of other control that we didn't have over our variables in Python. Because that stuff's easy, but we lose a lot of control when we do that. Now the command prompt. I think I was trying to get you. So come over to the project, right click, and under properties, all the way at the bottom is this list of properties found. So a whole bunch of different things. The libraries that we're using, we can add more, set those up. Kind of like the installers, referring back to those who are familiar with Python, we can import a library and use it as long as we've already installed it. So this is where we would install the libraries, which we actually have to manually do. We don't have something like pip or anything. And manually install it means we have to download it from somewhere on the internet and copy and paste it onto our computer, and then tell our project that it's on our computer. It's not an automated process. Under build, start compiling, packaging, deployment, a whole bunch of things. There's some other stuff. Runs the one we want. I'll come back to that. Things about the application, so some details. Who made it? When did you make it? Details like that you might want to put on there. Things for the license. A bunch of stuff set up. Different things we can do. But under run, you'll see this box right here that said for arguments. Oh, it's not going to highlight here. But right about halfway down, when we run, we're going to start at the joke.joke file. Our main class is in joke.joke. So we have to explicitly say where the main is, which everybody probably saw in Python as well, right? The file we actually hit run on gets renamed as main. So we have that guard statement in Python, if name equals main. The equivalent is just what is our main class in Java. We have to say everything has, every file in the project has code that can run. So we have to say which one we actually want to start with. And then our arguments get passed in right here. So pass in knock. And that's like the stuff we would pass in the terminal. okay, and then when we run it, we get the joke part. So it registered those arguments, who's there, the algos, and get that little cheesy knockout joke. Or it wouldn't be too difficult to add a couple more selection structures and extend the knockout joke out, right? So, but slowly looking at this stuff, we're going to see it over and over again. So I'm not going to talk about it once and expect you to know it. It's going to stretch out. We have 16 weeks. We want to build a really good foundation. Is so after the break, first thing we want to look at Java docs, right? So coming out on Java 11, I think. Just Java docs. Nope, that's the installation. I'll just look something up. Input stream Java. That's what I was going to look up here in a moment. So right at the top is docs.oracle.com. So this is the website that is generated from the documentation, those Java doc comments. Have this big overview. Our Java language is huge. Even in 16 weeks, if I stood up here talking this fast, trying to talk like an auctioneer, I'm just scrolling through the list of libraries. Those have sub-libraries, and there's lots and lots and lots of things in Java. So even if I stood up here and talked like an auctioneer for 16 weeks, we wouldn't list them all out. So what we want to do is build a good, solid foundation. Things like, where do we go find our objects we need? The official documentation. And they're really, really another one of those consistencies that commonalities is to build Java docs for the Java docs for every object we create. That way we all have the same type of documentation, we know how to navigate around it and stuff like that. And we'll take a look at some of this after the break. But there's a lot to the language. So we want to build a good solid foundation. We will see this stuff repeated. Does anybody have a question? Any questions before we take a break? Just 10 minutes sound good to everybody. I know I'm getting a little thirsty. And then we'll come in here and look at this thing that I pulled up, the one I wanted to look at after the break. So my laptop says 7:08, so we'll get back to it at 7:18. We'll stop the recording. And I made coffee before this time, so I know I have some coffee right over in my office. Where's the stop recording button? Oh, that's it. All right, before the break, we were kind of looking at an example of taking our time with a little example, passing in some terminal parameters as we start our application, how to do that both in one of our terminals and in our IDE. I wanted to take a look at a couple other things as we just kind of ease into stuff this first week. We're doing spending 2 weeks on each module so we can stretch things out and look at it. One of the things we looked at right before the break was the Java doc comments. Specialized comments that we can put to like a multi-line comment, only we use multiple asterisk characters. Yeah, that'll be fine. We'll take a look at it in a moment. Something in the chat room. So we have these special type of comments that are part of the Java language. So they weren't even, that's not something we do in the IDE. That's really anything with comments. We do in comments, that's part of the language, not one of our extra tools. And notice when I created that, it already recognized the parameters this method's expecting. We'll set that all. We can list out what parameters our methods take and what they return and give a bunch of details for somebody to read that comment and see stuff, but those will generate websites. In particular, they'll generate a website that looks like this. Standard edition 7. We're on 8 now. You just If you just installed Java, you'd be using 8. So when we build Java docs, we'll have a slightly different style sheet. It's very similar. It hasn't changed much. We have the same buttons, but they changed the style sheet for it a little. So get a little bit different color. To list out all the things, there's a lot of them here, sort of a standard one. We'll come back and look at this at different times. But it generates a website like this. So like here's an input stream object. I was going to talk about that. As we come down, it lists out all our methods. So there's this method that returns an integer and doesn't seem to take in any parameters. Or down here, there's this method that takes in an integer and returns void. So it doesn't return anything. So all that information that we put there, what parameters our methods need, what they return, a quick description of it, all that builds this website. And come down here to the longer version. There's parameters, and then we don't just see the name of it, we get a description of what it does. Description of what the method is, a description of what each parameter needs to be, a description of what we return, what it's going to return. We have very thorough documentation built right into the Java language, has been since the beginning. So it's definitely something I will be asking for this semester. Put that stuff in your comments where you can generate the Java docs to get used to that. One of the things about Java is that consistency. I'll do things the same way, and it's really, really easy. Just when you put a comment like /**, and then several lines of comment, and then you get down to the bottom */, and then that comment will be used to make a website. And then we can link around to different things. All the different packages, all the classes that get used in them. I'll click on print. So things for printing. Pageable, printable graphics, book format. This is actually the module to set up a printer. You know, when you hit that print and then that dialog box comes up and you have all those options. These are the libraries for writing that program. That's a good one to know. A little bit less useful than it was maybe 15 years ago when we would print everything, but it still exists. So you can see we click through there, we see all the interfaces and objects and errors that are built into that library, the ones specific for the printer stuff. Click through there and see everything about this book object and the methods that are in it, the constructors we have. There's only one in this case. All the methods we have in it, the stuff it inherited from other objects, and all the documentation, all the information you need to work with that is in one place. Which, starting out here, that's going to be overwhelming and confusing, right? We can go to tutorials. So those who have had me before definitely heard me say this sentence. Always look at official documentation first. It's going to be confusing. It's probably going to confuse you worse than when you looked it up to begin with. But look there first, then go to a tutorial, and then follow along the tutorial, which is nice, simplify, make sense of it, and use that to learn to read the official documentation. Because if you just follow the tutorial, you're only learning that one and only one thing. You're going to have to go back to the tutorial for every single thing you do. But there is official documentation for everything that can be done. So don't just use the tutorials to learn that one thing. Check your official documentation first, watch the tutorial to learn the thing you're trying to do, and then go back and look at the official documentation and be like, oh, that's what they were talking about there. Because then you understand how to work with that. And tutorials go out of date. Anybody that had me for anything that covered Python in the last year, we would have seen that because last October, half of the tutorials on the web were out of date. unless they were the super basic intro to Python, like this is the print statement. Anything beyond that, even some stuff about the print statement went out of date, was outdated last October when they moved to the latest big release of Python. So tutorials get out of date, but official documentation will be up to date. So for those who haven't seen me before, use the tutorial to learn to read the official documentation. So that way you're learning the language, not that one particular thing. And it doesn't take much. So it's just when you search for it, look here first. It's not going to make a lick of sense. And especially at first, it's probably going to confuse you worse. Then go check the tutorial. That'll make sense. Nice Geeks for Geeks. They have great stuff. All the stuff on you, a lot of good things on YouTube. New Boston has some of the best stuff for websites, or like his channel, and he redoes them Java was one of his original things, and he redoes them every 3 or 4 years. He has some great Java stuff. The New Boston. Check his tutorials out, and then come back and look at the documentation again to see what that was doing the first time. And then you won't need the tutorials. You'll be able to look at the documentation and be like, oh, that's methods that work, and throw your stuff together. And because tutorials are restricted, right? You only see part of it. If he was going to talk about an input stream in the tutorial, you're probably only going to see like one method. I might show read. They're not going to show read byte or read a bytes integer and a read byte all in length. They're not going to show all the different reads in the tutorial. But in your case, you might need that particular one. And that's the one I want to look at. So reading the file, we looked at the scanner. I'm that on the thing here. So still kind of in preview mode. We're going to see this in more detail later. Preview mode here, kind of looking at all this stuff, just easing into stuff. We still got 16 weeks in this class. Most of the stuff's gone to 8 weeks. We have a scanner where we read the keyboard. There is a file object we can pass in here. And for most of the stuff in the class, that's probably what we're going to do, because that's the easy way. And we are very restricted on time in a classroom. I just said we have 16 weeks, which is kind of nice for the class, but that's still a very short amount of time to learn as much as we possibly can about Java. So we could scan a file, which is a file, gives us a file handle. And we have our RAM. For those who have not had me in class before, we often use stack heap diagrams. So the stack is our code, the instructions we write. They get fed into the machine as a stack. So this text file we write, in the case of Java, it gets compiled. That compiled code gets read in backwards. So it reads in the last line, then the second from last line, third from last line, all the way back up. And then up at the top, there's the first line that we wrote. And then it starts popping things off the stack. A stack is the last one to go in, it's the first one to come out. Like a stack of plates, right? We wash our dishes, put them up in the cabinet, and then next time when it's time for the next meal, we grab the last plate we put on that stack. We grab off the top of the stack. So kind of the same thing, we feed our instructions in backwards. So this is our code. And then it's processed as a heap. We'll talk about what a heap is when we get to data structures later. We might make a heap. I know our textbook has an example of a heap, like follow along example, where it's one of those where they leave several sections out. So we just have to figure out those last 3 or 4 lines to make a really, really nice heap. But we'll at least talk about what those are in detail, but it's dynamically allocated memory. So this is our RAM, our random access memory, what we actually have to work with. So that's the stack heap diagram. I'll use these a lot to describe what's going on in a machine. So like when we have a file handler,
We also have storage over here using the standard UML symbol for database, long-term storage. And that's going to have our file on it, right? Over here somewhere in our database, we have this file. So a file handler will make a reference to it over in our code. That points to a spot in memory. And in the case of a file handler, which everybody in here, I keep saying this, everybody in here has seen Python before, right? I see head nods here. Because I know a bunch of y'all haven't solved Python with me in class, so I keep referring to that because everybody's probably seen it. So that's what we have in Python, a file handler. And what's stored in memory is a pointer to that file. Actually, it's a bunch of pointers, a pointer to each line in the file. Each line gets its own pointer, so then that's why when we're working with the file handler, we'll loop through the lines in the file. But for a picture here, I'm just going to draw one pointer. Hopefully that isn't too oversimplified. It makes sense that it's just a bunch of arrows and would look like a mess here. So a file handler points at that file. So we ask for the first line somewhere in our code, and it's like, okay, we're pointing over here, grab the first line, come back through, bring that in. Okay, grab the next line, go over here, bring that back, spit it out to wherever we're spitting it out over here. And we're basically grabbing that whole section at a time. We can modify file handlers and do the whole file at a time. We never actually bring the entire file into memory. Right? Remember, the file stays over in storage, and memory just keeps a reference of where it's at on the hard drive. So we keep bringing that through, but we bring through the whole thing at a time. We can do better, right? Y'all probably already saw the name that I pulled up on the screen. Because, yeah, like with the one arrow here, we're pointing at the whole thing. We need that whole file every time. And that's it. We either grab it or we don't grab it. We can do much better with Java. Much better. So if I come back over here in our example in Java docs, so instead of using the scanner on the file object to do a file handler, you do an input stream, which actually everybody in here probably knows that word, right? Stream kind of shows up a lot in our society. That is actually named after things we're going to learn in this class. A streaming service. When we write our servlets, the primary method we're going to use is service. And when the service that we create sends a stream, that's a streaming service. So you actually have a homework assignment on it, module 7, maybe 8. One of the last couple of homework assignments. You're not going to make a video streaming service the way we colloquially use that over and over again. But you will have to make it, you will have a homework assignment making a streaming service. Probably streaming a text file. Because instead of grabbing that whole file every time, well, we just grab a few bits. So back to a picture here, and I'll do it in different colors. Instead of grabbing that whole file, we could create a stream. Let's set up some spots in here. Let's say we have 1024 bits. That's a common number, right? So what we're going to do is we have a pointer to that same file and then a secondary pointer that keeps track of location. So we're going to grab the first 1024 bits, use those. And then we'll come back and grab the next 1024 bits and bring those in. Then the next 1024 bits. So our file does actually exist in memory, just in a size of our choosing. We can bring in the whole file as long as it fits, right? Obviously, there's storage is usually much bigger than RAM, so there is a restriction there, but we bring it in a little piece at a time. Or You set up a couple buffers. We fill up this one. And then while we're using this one fills up. While we're using this one fills up. Or we fill up this one to get us started. And then while we're using that, those two fill up. So then we're 2 buffers ahead. So when we get back, then when we're using this one, we have a couple more fill up. And we can add, that's sort of what a stream is. So that's hopefully that seems much better than a file handler and didn't get too confusing. We're just, instead of looking at our file, we're going to choose the size of it and just bring those bits through as we need them. So the video service would be like that last one. We do a little starting one, but then we create a whole bunch of other buffers. So while we're using the first buffer, we fill up a whole bunch more. And then as those empty, we keep filling up more buffers in the background. So it's staying ahead of the part we need, but we never actually use the whole file. Just doing it 1,000 bits at a time. We're going to see a small version of that. Obviously, a video stream's not going to fit. It's going to be hard for a weekly assignment, so we'll probably stream a text file or something, right? Stream a text file 10 bits at a time, 1 byte at a time, or a smaller scale of that so that it fits in our weekly homework, but much more power than we have in the languages where everything is designed to be much easier to write. The trade-off is obviously that's much harder to write. So if we're not concerned with speed and if a file handler is going to work, there's an easy way to do it. And but we will get up to streams. And there's other things here in the Java docs, the stuff it inherited from, but there's also all these things that inherit from input stream. So it's not even just one option on input stream. I'm not trying to know what's all this. Let's see. Got a string buffer, piped input. Look at a piped input connected to a piped output stream. If you're not familiar with that, that's like, I'll do an example in Linux real quick. Let me open up my virtual Ubuntu machine. Oh, I thought it was running. So I could ask for the IP address of this machine and get a whole bunch of information. It's like, oh, that's a lot to dig through. Alternatively, I could say IP address, then pipe, and that's where that name pipe symbol comes from. Then pipe that to the grep function. Can't remember exactly what that stands for, but there's an RE, like regular expression, pattern matching, where people have at least heard of regular expressions casually mentioned by this point. We're going to match a pattern. We're going to look for something in there. So I'm going to pipe the output of this into another function. So one function feeds immediately into another without multiple steps in between that involve us. We'll look for the word INET. And then we get narrowed down to just the IP, just a couple of single results instead of that big long block to search it. That's piping. Yeah, and actually directly seen that before. So there's a type of stream explicitly for that. Or an audio input stream. Specified format and length. Basically, as long as we know what type of audio we're listening for, go ahead and input it. But lots and lots of fine-grained control over everything we're doing. That's the advantage of Java. That's what we get from that little bit extra typing. Right? There's a quick and easy way to do it in Python, but we don't get this level. We don't have this level of control over the stuff in Python. General input stream, input objects like Python objects, strings. I don't even see the one I was looking for. I have to go further in here. Maybe it's because I went to Java. Oh, no, it's there. I was looking for buffered input stream. Buffered input stream. There we go. Somewhere in there. Oh, under filter input stream. So we can filter things along the way on the way in. And then filter a cipher for encryption. So in this route, we can go ahead and do that filter. All that fine grained control. Deflators, data input. Oh, or just the one that I actually put in the picture here, a buffered input stream, as opposed to a file handler. So we have better options. We'll see stuff like that throughout this semester. And obviously there's output streams as well. The two kind of go together. We're going to stream in, might as well stream out. But pointing to previewing the Java docs and the official documentation, like I said earlier, you want to use, if you're starting out into Java, use tutorials to learn to read the documentation, not just how to do that one single thing. Because then you'll know how to read the official documentation and you'll know how to read the instruction manual for Java. You'll know how to do everything that way. But if I go back to the overview page, start scrolling and I'll answer that later. I forgot to unsync that. We were dealing with something earlier today. I forgot to unsync my phone from the computer. As I start scrolling and scrolling and scrolling, you'll see there's a lot of libraries. These have sub-libraries in them and then full of objects. If I click on any of these. So SQL, we're going to see this one. It's kind of important to tie into a database, right? Need to connect to a database. Looks like these are mostly objects, so drivers, things for SQL data, an overview of what it looks like. Click on it, you get that big long description, then a summary of the methods there. You click on those and you get the detailed description of that, what it returns whenever it's done, the specific exceptions that it's going to throw. Just, for those who have worked with the database before, it was really, really quick, and we either have our results or we have an error, or results are -1, then -1, we just call that an error and deal with the error. That's something else we'll probably look at some point. Exceptions are quicker than anything else. Selection structures are really, really quick for machines to handle. So all we do is take two numbers and subtract them. If the result is 0, they're equal, right? If X is equal to Y, we subtract them, and if it's 0, they're equal. If we subtract them and we end up with a positive number, that means the first one was bigger. If we end up with a negative number, that means the second one was bigger. So really, really quick. But one of the most basic things for a machine to do, so really, really quick. But an error is even quicker. Because if we subtract two numbers, right? If there's 64-bit numbers, we have to subtract 64 things. If we hit an exception, we might hit an exception 3 bits in, which would make it even quicker than our selection structure. And sometimes code will be written that way. So I like to look at it in that in class because it is very, very confusing if you aren't the one that wrote the code. There's a huge long list of exceptions, and what actually runs is the unhandled exception. So the thing that you know is going to happen, or the thing you most expect to happen, you leave out of your code and handle all the other exceptions. So when you see somebody's code that's written that way, it's super, super fast. It's as fast as we can possibly get a machine to operate. If you're looking at somebody else's code, if you wrote it, then you know which one you left off, which one you left out of the code. If you're looking at somebody else's, you have to figure out which one they left off. And that is an interesting mental challenge at times. So we'll look at simplified examples of that throughout the semester. I really like Java. there's gonna be a lot of interesting things we see this semester. Hopefully stretched out, so it's not gonna be completely overwhelming or anything. We'll have time to practice stuff, learn skills. The big things tonight was kind of that first start and clicking a couple things on NetBeans, Java Doc. For starting out, just click around those things. Click on NetBeans, look at stuff. The computers here have NetBeans on them. Does everybody know how to log on to the computers here remotely? Do you have the instructions for that? Yeah, we have remote access to these. Actually, if you start counting the screens, the towers, you'll notice there's twice as many towers as screens. So half of them are set up for remote access. Let me grab the instructions. I have a live in my other one. I'll check that afterwards. That must be important. I have a lab for my other class, so let me just give you all the instructions. Oh, I have to fix this for my other class. We use a software called Beyond Trust for remote access, and it goes with the home campus. So who all is from a different home campus from elsewhere in the state? If Sellersburg is listed as your home campus, you should be able to get right in. But otherwise, I have to call up to Indianapolis and have the central office do that. But I tracked down who to contact up there yesterday. So it'll go much quicker than it did yesterday. But anybody from another campus or okay, so Texas up north. And I believe you're also from up that way as well, right, Dallas? I don't think you heard me. But anyway, there's remote access here. Oh, type it. Okay, yes, that's what I was thinking. Stuff from Indianapolis. So I can get you all added to our list here because we do have NetBeans and Jamf installed in our GRE labs. Your GRE labs will have an IDE you can use for Java, probably Eclipse, which takes a lot more customization. And you probably do not have a virtual server already installed because that's what's studied in the SDEV 111 where we build them. So the typical GRE lab around the state doesn't have the ready to go one because there's a class where we specifically build those. But I can get you all added to that list, and you do need to set up an account. So in the Informatics 109 class, I have everybody set up an account. So I'll just give you all the lab manual from this. That seems like a quick way to do that. So it's fairly straightforward. It's just this link. Use SAML, use SAML. Duo has to log you in. You can't type in a password. It's got to be whatever Duo is using these days, 88 characters. So it's got to be that big long string. So make sure you use the SAML authentication and then set up a guest account. You can log into all these machines here in the lab, and these do have NetBeans and Jamf on them. So download that, and our class is this one. Remote access GRE labs. I will go ahead and send off the class roster up to Andy so that you all from elsewhere in the state will be added back to the Sellersburg list. So then when you go to Beyond Trust, you'll see your local campus and the Sellersburg campus. And ours are in 158 and 162, and that's listed in this document. Here are the lab instruction. Remote access. VLAN. And check. From the paramedics, 109 class. So obviously you don't have to follow the whole lab. It's just getting started. Really, there's just some arbitrary questions. The thing in there is get everybody to set up an account. Right now, the guest account, oh, I should put it in here. Yep, username, so you can set up a guest account is SOIT guest for School of IT, and temp password is Sellersburg, but it's spelled wrong. He added an extra E, so sell ears or something like that. Which has gotten me a couple of times in 2022. So remember, there's an extra E in Sellersburg. If you're writing that, if you all elsewhere in the state, you probably have no idea the name of that small town anyway, so we wouldn't know if it's spelled right or not. So that's temporary, probably only be here for about 2 weeks or so to set up an account, and then these update 1 hour a day. Otherwise, it should be 24-hour, 24/7 access to these machines that are set up for our class. Just in case you need that. Let's see. That took a little bit longer than I was intending for it to take. Has everyone worked with GitHub before? Twice. You're familiar with it, right? We upload files, download, and send a link or repository. I will spend a little bit of time looking at that. I would like to take at least enough time to get into the details. So if you haven't dealt with it much, Git from the name GitHub, that's an instruction that we put in our terminal. Cross-platform. Linus Torvalds invented it. That's one of his big contributions. That's probably his biggest contribution, even though you know his name from Linux. Git has showed up even more because it's cross-platform. Every single system in the world uses Git. Not every system uses Linux. So a really, really big one. But we have that stuff. Okay, there's a file upload. I'll explain this. At least our small stuff here at the beginning, we create a repository, and then when you're on your repository, which I have one for this class already, we'll look at the command prompt ones because I want to make sure there's time to do stuff, and we're already less than an hour left, and I'm sure y'all are ready to do something instead of after listening to me, right? There is an upload button, so if you create a new repository, go here, and there's no limit on the repositories. You choose the organization. If I can't find something, I'll look for it. Put a folder for each module, randomly put everything at the top level. I'll look to see if I can't find it, I will ask you about it before. I won't just put a bad grade, I'll ask you where it's at. You do a different repository for everything. One guy over the summer class did a different branch for every week. So he had the same structure, and every week it was just a different branch instead of a different folder. But there's no limit to the repositories. You can do a different repository every week. However you want to organize it, you create a repository, just kind of give it a name, something useful, useful name. As that works. Quick description, generic class example. Delete this. Whether it's going to be public or private, please make it public. Otherwise, I won't be able to create your own work. Add a README that gives you a little descriptions thing. So if you want to add some notes, one requirement I will have you write ask for a bug report. Put little quotes on it. If you want to practice, you could go download a bug report template and kind of do it up all formally. I've seen people do it that way, but it doesn't even have to be grammatically correct. Just some quick notes jotted down about the problems you encountered and what you did to fix them. And it doesn't have to be grammatically correct sentence. Just, I want you to reflect on it one more time. It's good for the learning process, right? Preview, practice, reflect. So that last little bit of reflection is like, okay, this went wrong. I did this to fix it. Which is like a bug report. So some people over the years have found that they like to go download a formal bug report template, like they'll use working in the software development field, and get some practice with that. Filling all that out, like who would need to sign off and approve on it and things like that. But just give me a couple notes. I just want you to do that last reflection thing, and the README would be a good place for that. Throw it in the README or add it in your comments, put it in the submission comments. There's no real restriction on that. Just use the repository to get stuff to me. We might look at get ignores. There's not a built-in way to ignore parts of our code like we have in Python. So we can just have the repository, tell the repository which ones are packaging things, so we don't need those when we import stuff. And maybe a license, good idea to have those, the Apache license, the GNU license. BSD is the completely the most open ones, right? BSD, that's the license that basically says the developer is not responsible, do whatever you want with this code. Feel free to have fun with it. The developer is not responsible for any damage caused or that sort of thing. Stick a license on it and then we create it. And there's a button here to upload things. So you can just hit upload, and then to download, there's a download button as a zip, or the URL right here. And like I just said, Git is an instruction that every machine on earth is running. So we can do better than buttons on a web page. But I'm sure y'all are anxious to start doing some stuff with Java, right? Other than listening to me talk about it. So we're going to stretch things out. Still kind of in preview mode tonight, but that might have been a better example of how the class is going to go. Describing each detail, throw pictures up on the board to see the descriptions, and well, kind of almost directly like this, right? If we're working in Java, there's that competition of why would it be better to do this in Java than in Python? Python's going to be way easier. When is it worth the trade-off, right? Because obviously, if we're not concerned about the slower language and it's going to be really short, we don't want to do all the setup. One of those definitely stands out as a lot easier, not just a little easier. So we want to make sure we understand the trade-off of when it's better to do it which way. Because machines are really fast and easy. So we'll talk about those, follow along examples. It'll get more and more detailed as we move along. Yes. Here, I'll upload the example here just to show you what it's like. Let me grab the repository. We'll talk about this in detail, Jesse. So you haven't seen this before. So to wrap up, I'll do a quick pass on this, preview pass on this. I'm going to grab the link. I already know what it is, so I'm going to go ahead and grab it, copy it. I'll go over to my terminal. The documents / delete. What do we call that tonight? Oh, second. Okay, here's the one from earlier. Clear. I'm in PowerShell. I should use the proper terms instead of the like PowerShell slang that's allowed. Get child item. There we go. So this is the folder with the right things in it. So I want to put this on GitHub. So I'm going to go up a level here in my delete folder, and I'm going to make a new folder called Git stuff. And now I'll go into that Git stuff, and that Git command. So Git, which it's not an acronym, it's not an abbreviation. Git is Old English for an unpleasant gentleman. There's a B word that made it over to American English, but we didn't bring for women, but we didn't bring. Git is the male version of that. And Linus Torvalds always names things after himself. Some people work alone because they like to be alone. Some people work alone because nobody will tolerate them. Well, with Linus Torvalds, people will tolerate it. They're happy to get screamed and cussed at by him, with all he's done in the world. I've mentioned his name a couple times. Does everybody know who I'm talking about? The guy that created Linux. He created Linux, created Git. He did a lot of stuff, but he's notoriously difficult to work with, and he names things after himself. So Git is old English, British English for an unpleasant gentleman. So we'll use that to init or initialize this folder, and then the dot operator always refers to the folder we're in. So git init the current directory. And if I pull this up over here now, documents, delete, still in preview mode, but you'll notice some stuff showed up there. Some instruction stuff showed up there. So now I can add that. I can connect to that repository. So git remote, add origin, and I'll paste in that link that I just copied, which you can see is regular internet protocol, hypertext, secure hypertext transfer to github.com. Then the repository, and at the end is .git. So the .git extension on the repository. So we can actually do stuff with it. So add that, and then it will origin main. So we'll pull down the main branch. Which, if I look over here, I knew I've done it enough times, I knew the default branch was going to be called main. You might have to check which branch you want. So said it fetched a bunch of stuff, and we'll look over here, then there's the license and readme. That's the only thing that was there so far. But it pulled them down. So now I'll grab the example from tonight and copy, well, I'll just drag it. I don't think it's open. Oh, no, it is open somewhere. So I'll copy and paste that in. So now that's in the local version of the repository. So, sorry, I could zoom in so y'all can see all these. So we had git, initialize our folder, git remote, add an origin, pull that origin down, copy and paste our stuff over, and now we can say git add dot. So again, the dot refers to our current directory. So add all of our current files, and they were typed on Windows, so they have the carriage return line feed, and that's going to be. Oh, I must have modified my text editor. They have the Unix line feed, and that's going to be replaced by the carriage return line feed because Microsoft owns GitHub now, and that's how Microsoft does their line feeds. Because there are a few instances where that difference shows up, where when we do a line feed, we won't be at the beginning of the next line. So add our files, then we have to commit to those changes. So git commit -m is like message or name, the name or message saying what this one is. So Java class in class example, I'll give it some sort of name. So 2 files have changed since we downloaded it, and that between those 2 files, there were 17 lines inserted. That sounds about right from the example earlier tonight, right? And there's also a graphical thing where we can see this in picture format with lines highlighted in green and red, much clearer. And then say git. We pulled down to get it, so we'll push back to git push origin main. And now it's back on GitHub. So that's what it takes to do that. We will look at it in a few more detail, with a few more details soon, but it's basically those commands. Initialize our folder, pull down the existing repository, copy and paste over the new stuff, push it back up, or you could just keep a folder going. I usually pull it down each time and then delete it afterwards. So now I'm going to go in here and delete this, because if they're different, you get problems. It takes a whole lot more work if the one you have locally is different from the one on GitHub. So instead of keeping the local one going, I've just found over the years that it can be very useful to pull it down every time. It only takes a couple seconds to just make a new copy and then bring the new files in instead of trying to keep them going. Which that is built in, it is integrated into NetBeans. So there's some, we actually don't even have to go over to the terminal. NetBeans knows what GitHub is. Actually kind of wants to connect to GitHub. But now that that's deleted, if I come back over here and reload, you see there's the file from the seed. Oh yeah, so here's the new stuff all highlighted in green. 17 new insertions. So all of that's a new file. If we make some changes and then upload it again, there would be things, some things in red, some things in white, some things in green to indicate what was changed. It's a very, very powerful tool. It's more than just online storage. It's one of our primary tools. When we say import in our code and import a library, it doesn't have to be locally. We can import from GitHub. Any place we run Java code knows about GitHub. So we don't even have to do special things. Any place we can run Java code, really our Java virtual machine knows about GitHub, so we can just import straight from there. A lot of good reasons to use that. We'll see that in a little bit more detail. And just like a programming language, that's a huge, huge, powerful tool. There's a lot of stuff there. We will see bits and pieces of it. That's mostly what we're going to need. Oh, and then, yeah, to submit your assignment, you would come over here and send me the link. Or some link. If you want to, we uploaded it here, we could go right to the file and send me this link. But I'm going to pull down the whole repository and run it. So whatever link you send me, I have to come back up here to the top level and grab that link. So just send me that top level link to the repository. And however you want to organize it, go with what makes sense in your mind. If I can't find something, I'll ask you where it is. And usually if I can't find it and then ask about it, I'll have looked for a while, so I'll have a good understanding of how you organize things. So then I'll know where to look for your stuff in the future. Whatever makes the most sense, but that's what you will, then that link is what you will submit for your homework. A very, very powerful tool. Click around in NetBeans, there's different windows. But we're running out of time for JSP pages. We'll get to JSP pages soon where we're integrating our code. I was wanting to look at that tonight so you can start kind of mixing that and doing the Tomcat thing, but it will take a few minutes to make sure everybody's set up is correct and stuff. So we'll do that on Tuesday. And that leaves us about 30 minutes to just kind of put together some main methods, practice that main method. NetBeans will automatically generate it for you, but at this point, it's probably a good idea to go ahead and type it out to make sure it's committed to memory, right? That's what our main method always has to be like. So you just want to commit that to memory so that you never forget it. And your IDE will generate it. So after a couple practice runs where you have it committed to memory, then have your IDE generate it, or start doing some little things. We'll look at our primitive data types primitive data types on Tuesday, and then look at JSP pages where instead of a main running on our one local machine, we have a web page running on a server to get sent to the client. Then we have HTML and CSS to make our output look way, way nicer than a console. I'm the age that I remember when computers switched from console output to graphical user interfaces. And I thought I'd never had to look at I'd never have to look at all those text things again. It's still powerful, we use it sometimes, but we want things that look better than a console output, right? And we can do that with JSP pages, really easy, using NetBeans and Jam. So we'll jump in there on Tuesday with some other primitive data types, or integers, or booleans, or the stuff that chapter 1 in the textbook stuff that your reading assignments about. So I'm gonna start playing around with things. That leaves us 35 minutes left of class. I will be sitting here, or actually probably over in my office, across the hall, sitting and coffee. But I will be right by the computer, ready to jump back on the Zoom call in a split second if anybody has any questions. Does anybody have any questions before we wrap up here? Okay, and once again, week 1's preview mode. We'll see this we'll see it in detail, make sure we develop a thorough understanding and a nice solid foundation to build our understanding on. All right, text messages and Ivy Learn messages are the only 2 things that make noise on my cell phone during the semester. Biggest way to get hold of me from now until our scheduled time, which is 8:50. I'm gonna be sitting in my office waiting for questions to come my way. Please use our time productively. Learn something IT. Like, use it productively for your school stuff. I can't answer more. I do teach more than just the Java class, so I'm here to answer questions, but obviously during this time slot, if somebody has a Java question, those need to take priority from now to 8:50. Otherwise, I will see you all on Tuesday. Everybody have a great weekend. And it's not just 8:50, you can ask me questions anytime. That's just when I know I'm just gonna be sitting in a chair waiting for you to ask me questions. See you all on Tuesday.